So a very good afternoon to one and all present here. Uh, so I welcome you all in the last session of this 5-day faculty development program organized by Department of Electrical Engineering at NIT Kurukshetra on the topic electrical distribution system analysis with renewable energy sources. So today our expert is Dr. Nishant Kumar. He is an assistant professor at IIT Jodhpur. Before joining IIT Jodhpur, he was a postdoctoral research fellow at the National University of Singapore in the Department of Electrical and Computer Engineering. He has completed PhD from IIT Delhi, India, in the Department of Electrical Engineering, where his PhD thesis, has awarded the Best Thesis Award at IIT Delhi. His PhD thesis has also awarded to the first prize in IEEE IES Society thesis content 2020. Moreover, during his research, he has received POSOCO Power System Award for his PhD thesis, and also Indian National Award in doctoral category and ISS PhD thesis award 2020 at IISc Bangalore. He has completed his MTech from NIT Durgapur, where the university had awarded his research work to the gold medal. Gold medal. In between his MTech and PhD degree, he had worked as project engineer at IIT Bombay. He had also completed his bachelor's from Silicon Institute of Technology, Bhubaneswar, India, where he was awarded to best technical student. Recently, he is elevated to the IEEE senior member as an IEEE senior member by the IEEE USA and Young Scientist Award by Government of India, Department of Science and Technology. Uh, Dr. Kumar have published more than 60 journals, including 25 IEEE transactions and 8 Indian US patents. He is a fellow member of the Institution of Electronics and Telecommunication Engineering Society and also serving as an editor in the few IEEE transactions. His area of research interest include optimization, algorithm development, renewable power generation, microgrid, smart grid, and application of adaptive control and optimization in power and energy sector. So, with this brief introduction, I am handing over session to you, Dr. Kumar. So, over to you, sir.
Thank you, sir. Thank you. Thank you so much for this kind word. First of all, I'm sharing my screen, then we will start.
Yes, it's visible.
Okay, sir. Okay. Okay. Good evening, everybody. First of all, I'd like to thank the all faculty members and the volunteers who are involved in this FTP event, which are going on, and especially I'd like to thank HOD Dr. Ashwini Kumar and Dr. Atmaram Gupta sir for giving me this opportunity. And at the end, I welcome you all for this session. In this session, mainly we will discuss about the impact and the control related issue in the solar grid, solar based electric vehicles, means solar based charging or maybe the solar based direct electric vehicle. What are the issues is there, and some possible solutions also I will share with you. During this whole conversation or discussion, few basic things I will also touch, and then again I will pull you on the peak. So, sorry. Yeah. About me already, Dr. Atmaram sir has all discussed. So directly I'm coming on the topic. So topic is related to electric vehicles. So the first of all, the what is electric vehicles and why we are today more fascinating about this word and why we are also thinking about this. So in simple word, you can say the electric vehicles means you are going to replace or you can you can say you are going to replace all the combustion engines or fuel-based all the types of engine to electric motors. So in simple definition, you can say like that. Means the currently your all the wheels of the vehicle will move using your electrical based motor based rotational power. So this is the basics of the electric vehicles, you can say. But again, the question is it new? But no, this is not new. When you will see the history, then you will realize the electric motors is not a new thing, right? And when you will go in back and then you will see the invention in the area of electricity. So you will find the two most important thing is one is the motor, another is the light. From early day one, we are using these things, and we know the motor rotates, and also we know in car or in any vehicle, all wheels rotate. But question is that why today we are thinking about this motor replacement on car. When you will think about this thing in detail, then you will find the main thing is price. Only due to the price, only due to the money, today we are uh, uh, thinking about this type of concept or this type of you can say the technology, because whatever technology are coming in market in the terms of publication, in the terms of patent, but only those technology uh, comes on the ground platform, or you can say that comes on in market, which whose are more economical, or you can say which impact on the our financial status is more significant, then only any new technology comes in market. Otherwise, for example, if you will think about the fuel cell, right? Currently, fuel cell based several technology, paper and patents are available in market. But currently, no one is thinking about the fuel cell. Everyone is thinking about the battery based vehicles. In fact, Tesla is also pushing battery based vehicles in market, and all the company Mahindra, Tata, all of the vehicles are coming based on the your battery based. But because these battery based electric vehicles are more economical with respect to the fuel cell, right? But after the 10 year, after the 10 year, when the price of the electricity, so this battery will increase, right? Then you will see the fuel cell based the technology will be come in market. So this is the basics thing about the technology and the reality. So currently, in current situation, the electric based cars are very cheaper with respect to the other options. For example, you can see on the screen, if you are going to use petrol based car, then you can see the here I have considered the petrol 80 rupees per liter, but currently in India now is 100. So on 80 rupees, you can see this is 5 rupees per kilometer, right? If you will purchase more efficient car, means the costly car, then it will go down, but it will still around 3.8 or 3.9 rupees per kilometer in the terms of petrol I am talking. Similarly, in the diesel side, you can say this is 3.9, where I have included the price is 60 rupees per liter for diesel. But currently, you can see how much is that. Then price is increasing, then this will also increase. Similarly, CNG also 2 rupees per kilometer. But at the same time, when you will think about the electricity-based car, you can see directly 0.7 means 75 paisa per kilometer. Here I have considered the 6 rupees per unit, right? The price of Delhi, 6 rupees per unit, and on that basis you can see this is how this is cheaper and economical with respect to the other aspects. And only this is the key your motive. That's why today we are talking about electricity and we are moving for this technology. It is. Yeah. And another thing is that why today, not before this. When you will see the price of crude oil, which are available in market, means the petroleum, then you will see during 80s, these crude oils are extremely cheaper, right? That this oil was very cheaper with respect to the electricity generation process. That time, electricity generation process was very costly, right? Coal was cheaper at the same time, but the thing was that the technology which we was using, that was very costly. Also, nuclear was not on that time in market. So that's why the price of electricity was very high with respect to crude oil, right? But currently, the generation of crude oil and demand of the crude oil is deviating from each other, right? We are in the 2020, so you can see that gap, the crude oil production and the demand of the crude oil. These things currently deviating from each other, and this deviation directly reflects on the market. And what will happen? The price of this crude oil will increase, and it has started, and now we all are facing. Okay, so due to this, we are thinking about the alternatives, and day by day, this crude oil production will decrease because we know all. So this is limited. So this will decrease, and the price will directly increase. And also, you can say same time, demand is also going to increase. Demand due to our luxurious life, because nowadays we are using different types of electronic equipments, that is mobile, car, TV, whatever, sensors, smart meters, everything. And these all electronic smart equipments is based on electricity, and this electricity directly coming from the grid side, and right. So this price will day by day, definitely it will increase. It is not going to decrease. Definitely in few country government is giving subsidy, right? Or in few country government is taking some extra tax also, tax to force the user to move towards the electricity also, because this electricity is a little bit cheaper with respect to the oil. So this is the, you can say that this is the prime thing which motivates for other options. Okay, similarly you can think about the pollution also. This is one of the factor. So pollution is day by day increasing, so we're trying to reduce this pollution also. You can see in Delhi, Bombay, or all the crowded city in India also, the level of pollution and the PM level, how it is high, right? Also earth temperature also, you can see day by day, due to the climate change, earth temperature is increasing, and this earth temperature it will directly impact on our glaciers, right? Hello. Yeah, it will directly impact on our glaciers, so, which are directly related to our life. Means the sea level will increase, and then so how it will directly impact on our overall life. So these all are the basic things why we are thinking about the electric vehicles. And at the end, you can say that the maintenance is also cheaper with respect to all the combustion based engines, because in combustion based engine you are burning your oil in the combustion engine, and then it relates to your piston, and then piston reflects this mechanical power in rotational through the gear, through your transmission system. But here you are directly sending your electricity on the motor, and motor directly converts this electrical energy into your mechanical rotational energy. So here this little bit is cheaper in the terms of maintenance also. So if you will think about the efficiency, this efficiency is also very interesting here. If we will think about the efficiency, we are going to compare with oil directly. If you are going to extract oil from the well, you can see that I have considered the one well, and through this well, one way is that we will take the oil, and then we will go for the refinery, and where we will refine this oil, and after the refining, we will send this oil in market. So you can see the efficiency. Efficiency means the chemical energy, the original chemical energy conversion into the usable chemical energy. In the refinery, you can see this is 82% around. Means here the loss is around 18% in the refinery. Similarly, in the transmission system, we are sending from the plant to the market, and then you can see the combustion engine efficiency. The combustion engine efficiency is around 13-14%. Sometimes more efficient engine you will see next 20%. Is extremely, right? 20% efficient engine means we are talking about the extremely costly engines, right? Where the moving part is less. So you can see this is the structure. In this structure, you will see if you are going to use this oil directly on the vehicle. So you can see this is only 13% efficient. 13% efficiency means the chemical energy, available chemical energy in the crude oil, and conversion in the mechanical energy, rotational mechanical energy. When you will compare this energy, then you will see this is only 13% efficiency. Similarly, in the same time, I am using this oil for electricity generation. just you see on the above, just here this generation is directly based on the crude oil, no coal, no thermal. I'm not talking about any type of hydro and all. Directly this oil I'm going to use for the electricity generation, right? And then you can see this is 33% efficient, and then you will supply the generated electricity from the plant to the market, the transmission line system, which are 94% efficient. And similarly, this electricity when you will use on your car. So this type of engines means the motors, directly you can say motor, these motors are 23% efficient, means how much chemical energy, sorry, electrical energy you will use, and then converted mechanical energy when you will compare this is 23%. So overall efficiency is 23%. So you can see this gap. This is a significant gap in the terms of efficiency. That's why we are also moving towards this technology. Here I have compared the oil, but currently we know we all have several type of options. Means the renewables, we can use hydro, we can use, means you are good. You have another options. You can generate electricity by other alternatives, and then you can use here. So this is also a very important and interesting fact here. But the question is how this technology are going in market. So definitely a new technology you can't push directly in market. Whenever you are trying to push new technology in market, so since the users are not, you can say, familiar with this technology, so they will, the faith of the user is lesser, and faith is very important for the product, right? So user faith is very important. Then only you can sell your product in the market. That's why the process is that this stage is that not only the faith, also side by side we can say a time frame for make your infrastructure or ecosystem for new technology. This is also very important. For example, if every user will start using electric vehicle, then what will happen? Overall grid will collapse, right? Because when you are using your electricity or you are using your electrical power for battery charging, then huge amount of current you are using for the battery charging. And different types of charger are available in market. Different types of charger means fast charger, ultra fast charger. What is this? These things are nothing else, just an amount of current. We were increasing amount of current, keeping voltage constant. That's why all the battery is going to charge quickly. Definitely, you can't go with a very high current. When you will use the very high current, then heating will happen inside the battery and battery may damage. But in a safe region, new batteries are coming. Battery with a special, you can say, heat transmitting system, or you can say heat sinks. Batteries with heat sinks. New type of heat sinks are coming, and then new type of chargers are coming. That's very good. You are going to use new type of charger and using huge amount of current. Just once. You think about your house. Currently, in your house, how much current you are using? Max to max 5 ampere. In extreme case, where you are using a geyser and everything of modern technology, then also you are not going to cross 10 ampere. It means all your transformer, local transformer, domestic level installed all the transformer and the transmission lines. These all are based on your current use limits. What amount of current you are going to draw from your all the type of electrical equipments, right? But currently, suddenly, everyone is going to use your electric vehicles with your 30 ampere, 40 ampere. In fact, some cases 100 ampere also. So on that time, just you imagine, voltage is constant. You are extracting huge amount of current. Then what will happen? Your transformer will burn, right? Definitely that current will come, but heat will produce. When heat will produce, then your transformer oil and the cooling system, current cooling system is not capable for these things, right? So here it takes some time to replace this previous or old technology to the new technology. So this is, you can say, transition period. That's why today your hybrid, first of all the technology is going in the terms of hybrid and then pure electric. Hybrid will give the two things. One, in the government side, if you will think, it will give a time frame so that according to the requirement, government can change all the conventional infrastructure for the new requirement. Another, user confidence. Currently, if you are going to say someone, okay, use your electric vehicle, first of all, he will ask, okay, suppose I'm going 500 kilometers away from my house. When my battery will discharge, then what I will do? Directly, this is the question. In this situation, you will say you find some port where he will find any port, right? So these are the questionable points. So user have less faith. So this will also give one option. You have hybrid one, means whenever if any issue will come, you can use your conventional, your combustion based engine also. So it will give some faith also. So this is also very important for pushing a new technology in market, right? So this is the way through which the technologies are going to come in market. But the last question is that the pollution related. Everyone is thinking about the pollution. So when electricity will come, then pollution is going to decrease, and pollution problem is going to solve. Is it reality? If everyone will start using electric vehicles, then pollution will go down? No, this is not like that. It will depend on the electricity generation. If, for example, in the current situation in India, uh, in India, when you will see all the generation chart, then you will realize 60%, around 60%, 58 to 60% electricity is generating using your coal or gas, or you can say your any type of petroleum or maybe nuclear. So using this 58 to 60% electricity we are generating by using these things. Okay, in this situation, when suppose everyone is going to use electric vehicles, then what will happen? Obviously, in the city level, on the society level, the less pollution, right? All the petroleum-based vehicles you are going to replace to electricity-based vehicles. So these will not create any pollution. But this electricity which we are going to consume, it will come from the plant. So here, when we will use electric car, then the generation will increase according to my demand, right? So here, what we are going to do, we are going to shift our pollution from city to a remote location where is our generation plants, right? So this is a shifting of pollution from society to a remote location. So overall, if you will think about country level, if you will think about a global level, so if you are using any the conventional generating plant or conventional fuel, so you are not going to solve your pollution issue. Here, it is very important that we have to increase our renewable, right, hydro, and the new type of other resources, right? So then only you can say your pollution is going to down in reality. Yeah, society level, I totally agree with this. For example, in Delhi, if everyone start using electric vehicle, definitely Delhi will clean. But what about the other plants who are nearby in Delhi? They will start generating more and more. And when more and more generation means more and more fuel or more and more your consumption. So this is not the right way. Similarly, you can see here in the figure I have shown, because this electricity which are using is coming from a plant, right? So this is not the right way to solve the pollution issue. So what are the other alternatives? Okay, so before going on those solutions, first we will see the type. So the what type of electric vehicles are possible and available in market in the terms of fuel. In the terms of fuel, if you will think, the first option is battery based, means you will use your plug to take electricity from the grid and charge your battery and use. This is the most simplest one, right? So which are popular in India. Another alternative is fuel cell, means in the fuel cell you will use the fuel cell generation system inside your car, and in the cylinder you will store your hydrogen gas, and this hydrogen, according to your electricity requirement, you will increase or decrease the nozzle, or you can say the valve pin of the gas, and this gas valve pin will reflect the generation. If you will open your valve pin, then more and more hydrogen will fall on the fuel cells and it will generate more and more electricity. So here the fuel is hydrogen, and the hydrogen is free, but no, this is not free. But process is how you will extract hydrogen from water. When you will think about this, then you will find the process is based on the electrolysis process. What is this electrolysis process? You will use DC source. I'm talking about the electricity. DC electricity. You will create one anode pole and cathode pole, and then when you will push this electricity, DC electricity, on anode and cathode, then you will see this water bond will break and generate hydrogen and oxygen, right? Means again you are going to use some amount of electricity to generate this hydrogen. So that's why this process is a little bit complex, and that's why today it is not popular, but believe me, after the 10 year or maybe 15 year, it will be extremely popular in our society. But currently it is based on our, again, electricity. And also this process is looking simple, but this is again so many problem is here. How you will store this hydrogen? Because this, when the hydrogen tank will blast, then it will create a huge issue. So the storage is also a big question. And also this process, electrolysis process, which is looking very simple, but it is not that much simple. So these things are also, this is one way, which is future of our electricity or electric car. The third option is solar-based electric vehicle. Means that one solar plate or solar panel you will install on the top of your car, right? So just for example, you can see here, one solar panel will install on the car, or you can say your whole car will made of this semiconductor material. This is also one way. Means you are going to manufacture your car using this semiconductor materials, and then when this car will move in your society or in a ground, and then electricity will generate and you will use. Definitely this generation, because we know the solar panel is only 18 to 20% efficient, right? When you will think about the uh, area area on the car, and the generation of this solar based generation electricity is not sufficient to run your car for longer time with a high speed, because this electricity will be lesser. I agree with this, but the question is, okay, it will not generate that much to run 24-hour our car and with high efficiency with a high amount of current. But the problem, but it can support, right? Whatever you are going to use, it can give 30% to 40% electricity uses according to your use. For example, suppose someone is using car for official uses, means going office and coming back home. So for them, this is 100% economical. Means when the car has parked in an open space, then electricity is generating. Car is not moving, but electricity is generating. Means what is the use of this electricity? Storing in battery. But same time, commercial vehicles which are running 24 into 7. So for those, this car, it will support in the daytime at least 8 hours with 30 to 40% electricity. Means how much electricity required to run your vehicles. So it can support like that. And as well as the technology and all the new types of you can say the concepts are also coming to increase this percentage, means generation of electricity, as well as generation of electricity by using the solar panel on the car. One side, another is the control side, and the third one is the usage side, means what type of motor you are going to use, right? Several options you have. So several type of motors you have. So which type of motors you will use? So researchers are working on these things. So how you can decrease this usage? That's why you can say currently in market, so many vehicle companies are making car based on the solar. For example, you can see on the screen, this is a Dutch company. This is a Lightyear. The rooftop, the upper top of this vehicle is totally made of semiconductor materials. Means no extra mechanical burden on the vehicle, but you are going to generate. This is the motive. We are not going to place one solar panel on the rooftop of the car. No, it is not the right way, because it will give some extra burden on the car, right? This mechanical weight of the panel. But here our motive is that we will use this metal on the top of car. And definitely here the thin film type of solar panels have used here for the manufacturing. Not only this car, also in the Australia you can see the 100% solar powered trains are moving, right? So here area is large, right? So on the rooftop of the train, the area is large. So here full length solar panels have installed, and this train is moving with 100% solar power in Australia, right? Similarly, you can see the different type of car also. Means, for example, you can see here, this is the different company, means like a Toyota, BYD, and those. These all are manufacturing a car, as well as the transporting buses also. And this bus is moving in Germany and China also. Means solar powered vehicles, right? So these are moving in society. This is not only a hypothetical concept. These are, but definitely the parallelly technology and research is going on. Okay, think about the control. What type of control you will use? So inside the control, if you will focus, then you will see the solar panel. Solar panel will directly link with a DC-DC converter, because the solar panel generation depend on your load impedance, what type of loading impedance you are going to place, then only this generation reflection means the generation is high or low or maximum. It will depend on the impedance which you are going to apply on the solar panel. So here, this for the impedance matching, or you can say for the maximum power extraction from solar panel, we in general we use a DC-DC converter here, right? So this is the one way to one converter for solar power extraction from the panel. Another bidirectional DC-DC converter for battery also, means that when generation is less, right? So that time this battery will also discharge and support to requirement of the electricity. On the other side, if generation is high, right, then that time this battery will use the extra energy to charge, right? This is the way of electricity management, right? And another converter is DC-AC converter. Suppose if you are going to use your motor, AC motors, right? So that time this this converter will require to convert DC to AC, right? So three converters you can see. If your motor is DC series motor, sometimes in some vehicles you can say DC series motor. That time this DC-DC converter will be here, right? So these three converters are in the car. The fourth one here, AC to DC converter. This is for the charging purpose. Suppose in the night time, or you want to use your car in the night. So that time you require some electricity in battery. So how you will fill this battery requirement of battery charge? So that time one charger, AC to DC chargers you will use, so that you can directly link your car with the grid, and you will convert AC to DC and then use for the charging. So these 3 to 4, sometimes 3, sometimes 4 type of your converter you will see in a single car, right? So this is the basic structure of that. Suppose this type of construction is called you can say online charging, or you can say the on-board charging. So different name has given. So this infrastructure. Off-board charging also popular. Off-board means the charger outside you will get a directly DC. You will get those direct DC, and that directly DC you will use for the battery charging. Then that time this converter will not require, and directly you can charge your all the battery and all according to the power requirement, right? So these are okay. Now we are going to discuss about the solar side. So when you will think about the solar side of the converter control, right? So this is the structure of the control. This is simple DC-DC converter, means this is buck boost converter, right? So this is nothing else. This is according to the you can say the DC link, according to the DC link, and according to the power availability on the solar panel. This DC-DC converter we use. This DC-DC converter directly indirectly matches the load impedance and force the panel to operate on a maximum power. This is the basic one. This nothing is new here. This is just a DC-DC converter. What is the use and how it happens? Just in this other slides I will describe how this converter works and what are the technology and control mechanism is there. I will discuss that. Okay, but the question is that when our car is directly linking with solar, right? This is the car and this is the rooftop, and then when this rooftop is linked with the solar panel directly, solar sun directly, no any obstacle is in between the sun and the panel, then you will see the characteristics, power characteristics. This is the characteristic of solar panel, means power versus voltage. Power versus voltage characteristic you can see. In this characteristic, you will see a single peak is there, right? Single peak, only one peak is here. So in this type of vehicle structure, sorry, the algorithm required to track this one. Okay, why this is required here, and why here some algorithm is very important. First of all, you have to understand the characteristics. On the y-axis you can see the power, and x-axis you can see the voltage. Means on the same time, I'm not changing temperature, not changing the solar radiation. If you will think about the instantaneous behavior of the panel, then you will see this is the power characteristics. Means that if you will change the voltage on the x-axis, corresponding power you will receive, right? If I will use the low voltages, then you can see the corresponding power. You can see that. Similarly, on a certain voltage, only on a certain voltage, the power is maximum, or you can see the peak of this power, and that voltage is known as maximum power voltage, or you can say MPP voltage, maximum power point MPP voltage. You can say that. Means, but question is how you will track this and how you will decide this rotating, this maximum power point voltage. For power system point of view, one thing you can say that, okay, this is a polynomial equation, right? And I will take a first derivative equate to 0. I will get the different coefficients and then double derivative and put in the same equation. I will see positive or negative. A value where this is negative, that is the maximum one. This is simplest one. In a first look, it looks like that. But the problem is how you will get this equation. This is the question is here. How you will get this equation for this characteristic? Definitely, the equations are available. But the questions, when you will see the equation, then you will see different variables. Variables means the physical points. Physical points means the solar irradiance, temperature, dust layer. Temperature means cell temperature. Temperature just above the semiconductor material is panel, and the downside means the P type of material. Downside, the another temperature is downside, right? The second one. Third one is your dust layers. What amount of dust layer is on that? The fourth one, edges, means the edge side. What are the water droplets have created? How much error or how much issue, or you can say impact of the water droplet on every cell, right? So that is also important. When these things, when you will capture, if shadow is falling on that, the area of that shadow. So if you are able to find out these things by using different sensors, then only you can say I can plot this curve or plot this characteristic. But this is not a optimal solution. Means that during running your car, you will store these, collect this information, right? But question is how much sensors you will place, right? If shadow will fall, then how you will collect those information? How you will measure the dust layers? So when you will think all that, then you will find this is not a physical or even a real solution, a real market solution where to create this develop a algorithm or develop any technique to get this voltage for maximum power. And also the solar radiation is going to change and temperature also changing. So when these things are changing, then you will see the characteristics will be also reflect. You can see here, if your solar irradiance is changing, then you can see here on the left hand side, you can see the different peaks, and the corresponding voltage on the x-axis is not a linear relationship. Different solar radiation means different type of temperature. So different type of operating voltage on the x-axis you will see. Similarly, on the right side, when temperature is changing, then you can see your peak voltage, corresponding voltage related to your peak is also changing. But the question is when both will happen, and as well as not temperature and your solar irradiance. Also some fault due to the edges, water droplets and the side edges, as well as your dust layers. When you will include all this, then you will see this characteristics is extremely meshy, or we can say develop this characteristic is extremely complex in real time. In real time means here the word real time is related to your converter operation. This is not an offline problem. Offline problem is something else. Means when you are going for planning, when you are going to decide, take any decision, that time problem is something else. Means you have enough time, go for the equations, derive and take all the constants and multiply and subtract and take the decision accordingly. But here it is not like that. Here this is based on your real-time system. Real-time system means you are generating your operational switching for the converters, and converters is operating accordingly, and then you are deciding what is the power. For example, in this characteristics, different voltages is that these are the operating voltage, and by using the DC-DC converter, you are going to decide this operating voltage. When operating voltage is changing, then you can first of all you will operate on that voltage, then only can say what is the power. For example, here on the 5 volt, when I will operate, then only I can say okay, power is 20. When I will operate the same panel for the same instant on the 10 volt, then only can say, oh, this is 50, right? So this is operating voltage. So how you will do? So this is that. Similarly, in the 3D diagram, you can see, right, the characteristics, how characteristics changes, which time changes and the characteristics changes. And in this characteristics, x-axis is voltage and y-axis is the power. And this voltage, selection of this voltage is the most important thing, right? And this is not a linear thing. This is not below that. That's why I have plotted this figure. Here you can see the red line. So you can see this red line is not a linear one. This is a, you can say, exponential decay, or you can say this is a not a nonlinear equations is that. How you will decide that? This is the very important. Okay. For laboratory purpose, when you will derive this all your construction means panel as well as your battery of the car, right, and the panel which is on the rooftop, you will see this is the simplest your circuit. In this simplest circuit, this is your DC-DC converter, right? And this DC-DC converter force your panel to operate on that operating voltage where the power is maximum, right? Because already we know the efficiency of the solar panel is 18 to 20%. Already it is low. And here, if you are not able to extract that 20%, which is on the panel, then you can imagine how much lossy system you are going to use, right? So that's why this selection or this power extraction is very important. Through one example, I want to show you how this converter will force to operate on that. For example, you can see here. In this example, I have taken the basic equation of this converter. Basic equation of the converter means boost converter. So you can see here this basic the relation between input and output voltage and the duty cycle. Duty cycle means the switching behavior of this. Duty cycle means T on divided by total time. T on means for how much time you will switch on your switch, and then and a T of time means for how much duration you will switch on and how much duration you will switch on. This decides through using the duty cycle, right? D equal to T on divided by total time, right? Okay, so this is the relation V out divided by equal to 1 minus D into V input. This is the basic relation. Okay, I am putting converting this equation according to the circuit. In the circuit, you can say output side is battery, right? You can place here V battery. What is input side? Input side is panel, so I can say VPV, right? When I will reconstruct these equations, then you can see VPV equal to 1 minus D into V battery. Okay, battery side. You know the behavior of battery. What is the behavior of basic behavior of the battery? The voltage fluctuation in the battery is very low, extremely low. When battery is 10% SOC and the battery is on the 100% SOC, when you will see the voltage fluctuation or voltage change is very less. More or less, this is constant. I'm not talking about the constant, but for example, here I am taking the constant for your understanding. This is not constant, but here, for example, I've taken the V battery is 200, which is on the output side. Just you take different duty cycle D value, then you can see the VPV. For example, I have taken the 0.1. Then you can see when I've taken 0.8, sorry 0.1, then you can see the operating voltage. The operating voltage means PV voltage is 180 volt. Similarly, in the same structure, same instant, if I will take 0.5, then you can say this is 100 volt. Similarly, if you will take the 0.8, then you can say this is 40, right? 40 means 5 times lower than that. So it means that by using different type of duty cycle or different type of deselection, switching behavior, we can change the input side voltage. Input side means PV side voltage. And you know that this voltage will decide the power. You know this inverse parabolic curve of the solar panel, right? Where y-axis is power and x-axis is voltage, right? And these things. So here the question is how you will choose this D. This is the very important. How you will decide, and you know, and whenever you will operate on that voltage, then only you can see the reflection of that power. Means what is the instant power of that moment. This is not because you don't have that characteristics, right? First of all, you will decide the D, operate the converter on that, then you will measure the output power, then you unically say, okay, this is the duty cycle, then this is the power. Okay, change the duty cycle. Then when you will change, then you will again experience the new power. Change and experience new power, change and experience new power. If everything is constant, then it is okay. But it is okay, it is constant? No, because sun is rotating. Solar temperature is changing, right? And wind speed is changing. Wind speed will reflect your dust layers on the panel. So everything is changing. So in this situation, you don't have enough time to operate one by one, and then you will decide where this is, right? So it is a very fast operation. Okay, when you will think about the different type of maximum power point tracking techniques, then most popular one is the Pattern observe, right? So that I am trying to explain here how it works. The operating, or you can say the Operation of this spider when observed is based on, you can say, operation and observer behavior. Means that why this is name is pattern when observed means one by one you will operate and then you will decide what is operation and what is behavior. You can understand through these characteristics here. For example, I am operating on any point in middle. I think my cursor is visible to you all, right? Suppose this one is my operating point where my cursor is. Suppose I am operating on this voltage, x-axis voltage, right? And this voltage I am going to operate. When I will operate on this voltage, then I will get this much of power which is on the y-axis. Okay, I will note down these things. So next time I will increase this voltage. When I will increase this voltage, right? Increase the voltage means x-axis I am going to increase. When I will increase this voltage, then you will see the power is going to decrease. When power is decreasing, power decreasing with respect to the previous one means what it means. It means what decisions I have taken. I have taken a random decision. I will increase my voltage. When I increase my voltage, power is going to decrease. It means what? It means my decision is wrong. So what I will do next time, I will decrease my voltage. Okay, you will decrease. When you will decrease your voltage, you will find a new power, this one, and just you compare with the just previous one. You don't have all voltage as a power, only you have selected one, just last one. Just you will compare with the previous one, then you will see if you are going to decrease voltage, then you will see the power is increasing. Power is increasing, voltage is decreasing. What it means? It means what decision I have taken, that is right. Again decrease, again power has increased, again decrease, power has increased, again decrease. When you do like that, then you will at the end you will go on the peak, but still you don't know you are peak or what. So what you will do, again you will decrease your power. When you will again decrease your voltage, then you will see some other power which is lower than the previous one, less than the peak. What you will do, you will assume, okay, your decision is wrong. Now you will don't decrease your voltage, now you increase your voltage. When you will increase your voltage, then again you will go back on the peak, right? It means what? You have decreased it, this increases your voltage, power is increasing. Then what you will do next time? Again you will increase. When again you will increase your voltage, then you will go on the third point, right? And here you will see power is decreasing. So like this 3 point, this on this 3 point, you will start oscillating. That is the oscillating behavior of this algorithm. But anyway, the step size of this is depend on your what is the change. If you are taking a smaller change, then the oscillation is lesser. If you will take a higher change, then it will be bigger. So that's why the name of this algorithm is also 3-point, 3-step operation of P&O. And this technology always, this technique always rotate or oscillate on the peak. This is nothing is new here. Just for your basic things, I have touches this thing. Then I'm coming on the new our original work. So this is the waveform when you will operate this P&O technique on your any panel. Then you will see this is the voltage, current, and power. You will see in each voltage and each current, you will see this 3-step oscillation. This 3-step oscillation is only due to that, right? This is your peak selection voltage or peak selection duty cycles, right? Again, the question is that you will say, I will take a small change. If you will take the small change, then it's okay. Your oscillation is not significant. But when the solar irradiance will change, for example, here your voltage, you are going to change. Irradiance has changed. Then you will move from one location to another location. If this change is lower, then it will take a longer time to move from one to another, right? So this is the you can say the drawback of that. So and here this duty cycle change selection is very important. How much you will choose, that is the optimal one. Okay, this is the related to the basic one, but the original problem is not that much. Original problem is this one. When the car is going to move in the society, then the situation is like that. See in the society, here cars are moving here and there and all. Is it possible that sun directly interact with your panel? Is it possible in the society? So sun will directly interact with the panel? No, it is not possible. Whenever you will change your your vehicle will move, then the shadow of the building, shadow of the tower, shadow of the tree, or shadow of your neighboring vehicles also, that shadow will fall on your car. This is very obvious. This you can't avoid that. You can't say that I will operate my vehicle in an open space. It is not a real or feasible thing, right? always you will rotate your car or move in a society where this tree, tall building, towers, and the vehicles and the buildings, definitely it will be. When these things will be there, then what will happen? Shadow will fall, right? Whenever shadow falls, then what happens? The question is here. When shadow is not falling on the car directly linking with your sun, then see the situation. Your power characteristics is very simple. This is a single peak car characteristic. Means this is a power, voltage, and this is a single peak. But when shadow is falling, then according to the shadow behavior or shadow area, your characteristics is look like this. And in this characteristic, on the top, you can see multiple peaks, right? You can see multiple peaks here. See? Similarly, when the characteristic is something else, I mean, shadow is due to the different type of obstacle, then you see your characteristics are like this. And here, vehicle is moving. Shadow is also going to move with that speed. And according to that movement, this characteristics is also going to change with that speed. So here how you will choose the operating point. You can see multiple peaks. Out of all peaks, because we all are here with a background of power system. So we all know the behavior of these peaks, right? In these peaks, only one peak will be the highest one. That known as global maximum power point, GMPP. But question is, how you will choose the GMPP, right? Similarly, in this characteristic, this one is the GMPP. Here, this is in the middle one. And these characteristics are changing with a very high speed, right? Because the shadow is a fraction of time, right? When it will change, new building will come, new type of shadow, new characteristic. And the selection of this operating point means x-axis, your voltage, is very important, right? And another problem is that if you will suggest, okay, I will operate my vehicle in a, you can say, open space, means only on the highway, right? Like a Delhi to Mathura highway or any NH where the space is very open, you are going to operate your vehicle. Is it shadow will fall on that? Yes, shadow will fall there also, because the structure of your car, when you will see the structure of this car, this is not a roof type solar panel, so it is on a inclined location or position. No, it is not like that. It is according to your car curve, right? So here you can see the curved structure of this vehicle also creating different solar irradiance interaction. This is not shadow. This is not shadow, but due to different solar irradiance interaction. Means that which portion, the middle portion, which is directly linking with the sun, here the solar radiation will be high. And but at the same time, here on the downside, where the curve is down, you will see that here the solar radiation will be a little bit lesser. Similarly, on the upper curve, it is lower. Why this is lower? Because when the light is coming and light is colliding with your semiconductor material, then definitely all light will not going to penetrate, right? Definitely it will reflect. When it will reflect, suppose here the reflection of light will create some distortion on the other light radiations, right? Means here light will reflect, then it will cross the other lights, right? And this cross sections, light cross section, reflection light cross sections, it will create some decrease your solar irradiance on different portions of your vehicle, which is due to your curved structure, right? And then you will again, I'm not talking about the one position, this is 1,000, another position, this is 500. No, it is not like that. Suppose top one is the 1,000, then other one is the 990, 995 also, right? I'm not talking about the drastic change. No, it is a small change, and this small change is also capable to create or create peaks in this characteristic. And when you will study cell by cell, and then when you will draw the power and voltage characteristic of every cells, and then add up according to the series and parallel connections, then you will realize 5 watt per meter square solar irradiance is also capable to create peaks. That's why these peaks are very important during your power extraction, during your running time. When vehicles are running, and then power extraction is a very challenging here. right? Okay, and this type of issue is not only on the vehicles. I am going to discuss how you will extract, but this is a very obvious issue also on the other area also. For example, your snow area where the snow falls on the panel, then you can see the how these are creating the shadow on the panel, right? You can see like that. Another is the desert area. In general, we think desert is a very open space we will place, but see the great situation in desert area, the space is free, but also the dust layers. It also creates one your shadow on the your characteristic and how you will extract the power here. Definitely, one solution is that in general, people use the brush to clean on a periodic time. It moves above the your panel and it cleans. But question is that it will be the periodic one. Periodic means we will place the 30-minute, maybe 15-minute, very fast 15-minute or maybe 30-minute. In general, 1 hour every hour you clean. But in between, what will happen? In between, no wind, no shadow. Definitely, it will be. This is a very common thing. And in this situation, how you will extract the panel. Similarly, this issue is not only on the these type of panels and the vehicles, also on the Mars. The NASA has reported this issue also on the rover. Due to the storm, you can see the one figure here. They have reported this issue. Due to this storm, due to these dust layers, around 30 to 40% power generation has gone down, right? So here, this is very important that how you will choose the voltage, or you can say the find the operating point, or you can say the extraction. Okay, what type of characteristics you will see during your operation? Two type of characteristics you will see. One is this one, means your magnitudes are changing, right? And magnitudes are changing, but characteristics are more or less same. On every time frame, you can see the characteristics are more or less same. Means characteristic means the behavior, curve structure are same, and time changing, so your magnitude are changing. This type of characteristic is very rare. This is possible only when your say your shadow area is constant, and only shadow area will on this earth. Shadow area is constant. It is very difficult to say like that. On rover, it's okay. Sometime I can say it will be. This sun is not moving, so the on rover can get this type of thing. But on this earth, this is not possible, right? Or for rover, sometimes it's okay. But on earth, if even you are in the open space, the sun is rotating. When sun rotates, then again the solar radius will change, and this radiance will change. Then it will go up and down. Another is the most practical one. This one, on different time instance, different type of characteristics you will see, and different type of characteristics means the pattern, right? So different type of patterns you are facing on different time frame, and here the selection of voltage. For example, you can see the pattern 3, where the pattern 3 is written. The most right one peak is the global one. In the pattern 2, it is in middle side, and the pattern 1, it is on the most left side, right? And how your algorithm will detect that, and see the time also. I have noted the time frame, 1 second. Time is 1 second. Means after the 1 second, it is going to change. And why I consider this 1 second? Because according to the NERL US latest report, the considerable solar irradiance changes. Solar irradiance changes on every moment. But they have decided that means they have created one standard, right? Technology always based on the standards. So they have created this standard. So considerable solar radiance will change in 1 second. Means whatever you are going to tracking or searching, you have to finish within 1 second, right? 1 second, 1.0 second. Okay. So definitely this type of problem we can't solve by using any deterministic optimization technique, or you can use any mathematical based technique. That will not work here, because all the classical optimization or deterministic techniques, all the mathematics based, all the types of tracking techniques are based on the equations, where you are able to model your problem. But since this problem is difficult to model, right? And I will not say this is impossible, but still what is the cost of all the types of sensors, or what type of sensors are available in the market. So on that basis, we can say in current situation, where the panel is already costly, converter is already costly, then you are going to place these sensors, then it will be extremely costly, right? So in this time of situation, time frame, we can say this is impossible, right, for time frame. So simple one is there. The most favorable one is use your meta-heuristic optimization technique, because all the meta-heuristic optimization technique is capable to track or search in a black box behavior. Black box behavior means what is happening.
Dr. Nishant?
Yes, sir.
Yeah, sorry to interrupt in between. If you want to have rest for 5 minutes, you can have a break.
Okay, but I am okay.
If you're okay, then it's okay. It's fine. You can continue, please.
Okay, sir. Thank you, sir. Okay.
Okay, fine.
Thank you. Okay, very well. Yes. In between, sorry, when we will use your meta-heuristic optimization techniques, or meta-heuristic, or you can say heuristic optimization technique, then only you can track, or you can say the optimize, or you can say the find the best solution without knowing your problem behavior, right? If problem is changing or what is happening inside the problem, that is not your not important to know, right? Only two things is very important. What type of output you want. For example, in this problem, I want maximum power. What is happening inside the panel? Leave them. This is direction interaction, or maybe the shadow, or maybe the dust, whatever. I want maximum power. That is. So I have written here the objective functions. FD. This is the power, maximization of power. I want maximum power. Nothing else. What is happening? That is the issue of optimization technique. Another is the constraint. Constraint means driving points. Who is driving this power? Here, the DC-DC converter, and inside the DC-DC converter, switch behavior switch means the switch on, switch off time, which is known as duty cycle. T on divided by total time, duty cycle. This T on decides or changes the operating voltage in the input side, right? So here we can say this duty cycle is the constant, right? And the duty cycle is the in between always 0 to 1. 1 means totally on, and 0 means totally off. So that's why definitely it will not totally on, it will not totally off, right? So it is in between 0 to 1. So this is our constraint for this problem, and the objective is maximum power. P. Since this is a DC circuit, right? So that's why I've written VPV or IPV, right? Because we can't measure the direct power. Definitely the meters are available, but simple go with a small voltage sensor and the current sensor and just multiply. Direct linear multiplications, you will get the power, and objective is maximum power. Okay. When you will go for the literature survey, when I started my research, that time so many techniques researchers have uses. Okay. Different types of techniques. You can see the list here. I put it here. Different types of results they have got. But again, the problem started when I started my research in 2018, 17. So that time, this NERL reports and NERL standard had decided. And the standard was 1 second. Means the challenge is complete your searching within a second. You can imagine the small is how much small time, right? Definitely you required a high processor, but currently this processor is available, so it's okay. When I started my research, then that time only one technique out of all, right? I saw the list. Out of all, only one technique. Still, this is floor population optimization algorithm was available in market, which tracking time was 0.85 seconds. 0.85 seconds means irradiance is changing on every 1 second, and this technique was available to find out the global point within 0.85 seconds. Means what? 85% time you will invest for searching, right? You will search 85% time, and then only 15% time you will operate on a full strength, right? On the rating. This is the situation. This was the situation. And here the challenge was when I started my research to decrease this time, because we all know that the panel efficiency, nothing is new here. So how we decrease this searching time? So at least searching time will lesser, so we will able to extract more and more power. It means we are able to operate our panel on the global peak. global operating on global peak for maximum time means we were able to extract maximum power for longer time, right? So this was the challenge. This is the challenge here. So with this, I started my research. Definitely, I also my PhD started from 2015. So that time also I've gone with a different optimization technique, different results. But when this standard came in market, the all results was useless because the time bound is now fixed, right? So after all the techniques, I have not got any good result. Okay, so finally, we have decided we will go with a new technique. New technique means the dedicated technique for this problem. What is this problem? This is an online optimization technique. This is not offline optimization technique. I hope now you are able to understand what is the difference between online and offline. Offline means you have enough time, means you have enough time to plan or optimize, right? You have planning proper. For example, in Indian grid, I'm telling choose one location where I will place my StatCo. Choose a location. So what you will do, you have enough time. Sit on the computer model and run your load flow again and again, change the locations, right? And then you see where you are getting the good result. You have enough time. But here, if I will say find one voltage or one point where I will operate, then you will ask, what is the characteristics? I will say, I don't know the characteristics. So you will, so this is challenging, is very difficult because this is based on your converter. Converter means this is an online problem. Means whatever population you will create, every population you will fire, you will use for the switching. You will fire and then you will get your corresponding output, means the power, and then you will note down, and then in every iteration you will decide, okay, suppose you will take for example, you will take 100 population, then what will happen? 100 times you will fire your switch with a different duty cycle, and you will get 100 powers. Then choose, oh no, out of 100, the one is the global one. Next time, again, using mathematics, you will iterate, and then you will go for the next 100 firing. Okay. So you can say definitely now the converters are available with a 20 kilohertz, right? Means 20 kilohertz means 1 second, 20,000 times. It times looks very fascinating, but the problem is converters are 20 kilohertz, but converters, inside the converter, you will see two things. One is inductor, one is capacitor. Means when you are firing your converter, that time the energy is storing in your capacitor and in inductor, then switch is going to off. Then this power will go back on the, sorry. Then it will go back on the your, sorry, wait a second. Sorry, it is not, yeah. Inside the circuit, you will see the one inductor and one capacitor. And whenever you are going to fire, you can fire with your converter with a 20 kilohertz, 20,000 times in 1 second. But that results will not optimal because this capacitor or this inductor will take some time to store that energy and will reflect on that. That's why the exact result will reflect according to your time constant of the capacitor. So here in this operation, this capacitor, this switch maybe work with a 20 kilohertz, but the time constant of this circuit is the time constant of this capacitor. How much time it is taking to charge from one location to another location. This time constant of the capacitor decides the operating time, or we can say the time constant of the overall your algorithm. So in general, we take 10 milliseconds. You can understand 10 milliseconds. 10 milliseconds means in 1 second you have 100 times. Only on 100 times you can fire your switch within a second. 100. Suppose you think if you have a problem or if you have an algorithm with a population is 100, right? And your variable is 1, so 100. So in one, your population is 10. Only a small population you are taking 10. And when you will go for the iteration 1, it means you will run your algorithm for 10 times, right? And when suppose your number of iteration is 10, population is 10, it means 10 iteration will complete on 100 firing, right? Means 100 firing, 10 is population size, 10 is your iteration. Number of iteration 10, population is 10, then 10 into 10, this is 100. Means within a second, this 10 iteration will finish. Suppose if you are going to take 11th iteration, then your time is 1.1, right? So like this, it is increasing. Like this, it is increasing or decreasing. So here, this is very challenging. What type of algorithm will choose? select, so that you will finish your algorithm, sorry, your searching within time, because you know your iteration, timing, everything is fixed here. Okay, so first of all, for this purpose, this issue, because I 10 iteration, within the 10 iteration, I have to converge on the peak. And definitely not 10. If I will take 10, then it will 1 second. Our target is reduce the time. It means I have to finish my searching within 5 seconds, or sorry, within the 5 iteration, so that the time will be 0.5. If I will take 6 iterations, then it will take 0.6 seconds. Right. So this was the challenge. So that's why I have developed this new technology. This is human psychology optimization technique. This technology is totally based on your mental or psychological behavior of any ambitious person. In this algorithm, this is new algorithm, right? So here I have uses the behavior of any ambitious person, how any ambitious person takes any decision in the life. When you will think about that, then you will see the 4 emotional behavior. The 4 emotional behavior is the excitement, self-motivation, inspiration, and lesson. These are the 4 factors. Whenever give any task to any ambitious person, before taking any actions, they think on these 4 factors, and then they generate some positive power and positive energy, or you can say it generates some confidence to take any physical action. Before taking physical actions, these 4 factor works. And then after that, I have also checked the overexcitement and depression factor also. Sometimes you are overexcited, sometimes maybe you go down of your energy level. So it will also cross check in each iteration. Okay, whenever your energy is above the overexcitement, then some extra factor will work there to push back in the operating zone. And also, if you are depression, then extra energy will push, support will pull to pull in the operating region. If you are under the operating region, it will not work, right? For example, one example I have given here. Suppose this boy, right? This boy want to be a good athlete. First of all, what the things will come in the mind. Since he is young, slim, he have good health, so you can say he is excited for the work. Okay, he can, right? So this is excitement. Also self-motivation. Self-motivation means in the past, in school time, or maybe in village area, or maybe town, if he has participated in any this type of event, means that suppose he is going to athletics, so suppose school time he has participated and he has won that. Definitely this is school level. Now he is thinking about the national level, but that thing will also give some energy. Okay, you have little bit idea about that, how to run, and what the thing is, that it will give some self-motivation. The self-motivation. Okay. Similarly, the third one is inspiration. If he is planning for be a good athletics on the national level, then he will think about the who are good on the global level, then what they are doing. So that thing will also inspire them. What type of activity they are doing for become a good athletics. Similarly, lessons. What are the mistakes other have done, right? Miss all the failures, all the poor performer iteration, so population will give some lessons. So what mistakes they have done. So these 4 things play on your mental level before taking any physical action. This is the behavior, the normal human behavior. Also in the searching, during searching, how we will consider this here in this pictorial form. I have considered the 5 population, you can say, or since every population have 1 variable, so you can say there's 5 agents. In each iteration, at the end of the iteration, what will happen? All the according to the behavior, according to the performance, we will give the rank. You can see the rank position. He is on the top, he is the mid, the second one is middle, and these are the lower ones. Suppose he is C1. I am going to update his behavior. What I will do, first of all, he will one random vector, that is excitement. Excitement depends only on you, no other one, right? And excitement, with the time, this excitement goes down, right? When your confidence, when your maturity will increase, excitement will go down. I will show in the equation how this is modeled. Okay. Another is your self-motivation, means in the previous iteration, what was his strategy? So previous iteration will give the some one vector, that is your self-motivation. Another is green one. Green one is inspiration. All best performers who are away or who are good with respect to his current position, so they will give some energy level, that is the inspiration, and the all downside they will give some elation, means the blue color, right? So overall when you will include all through the equation, then you will see the final vector, that is red one, and it will motivate you, or it will update you for the perform better in the next iteration. This is the basics thing here. Also in the mathematical formulations, I have formulated everything in mathematics. So this is the basic equations, excitement factor. This excitement factor is the function of your enthusiasm factor, right? And you can see that your excitement factor is decreasing, is exponentially decreasing. It means your iteration will increase. You will become a more and more mature. But when you are doing same work again and again, what happens? Our interest, or you can say our excitement, goes down. Definitely, you become master, but the excitement goes down. Definitely, some person not agree with that, but this is like that. Okay. So another is your self motivation. The self motivation directly based on your previous iteration performance. So according to that, this is based on the spirit factor. Similarly, the other factors are also inspiration factor. Inspiration factor will calculate according to all the good performers with respect to the current positions, and also based on the three locations: low influence, moderate influence, and high influence. Suppose someone is doing good with from your family, right? And suppose someone is doing good who is away from you. Who will influence you higher? Definitely, who is more closer than you, because closer persons you can observe closely very good, right? So on that basis, this influence has also categorized low, moderate, and the high, and accordingly, this all factors in design. It is based on the enthusiasm factor. Another is your lesson factor. Lesson factor also based on your low, moderate, and high. It is based on the failures. Definitely, here again, who is closer one, you can observe better. Who is away from you, the impact of that portion is lesser on your life, right? So this is also categorized on that. It is a function of fear factor. Also, you can see how it happens. That definitely, if you will think about the influence factor, the good performer, suppose he is performing on a high rank, then you can see no inspiration factor is here because he is on the top. All the lesson factor is here. All the lesson factor will give here. You can say the one extra you can support in the terms of mistakes, what they have done wrong. So that will give you a good knowledge to continue his behavior, right? So this is that. But at the same time, lower rank holders, for the lower performer particle or lower performer agent, everyone is giving some confidence. So what will happen? His energy level will increase, and this energy level will give a opportunity to jump from lower to on a top position, right? So like this. Similarly, the consciousness factor also. Consciousness factor is based on your relations. Means for first one, the best performer will see all the wrong performance they have done, and accordingly he will make the new strategy. Similarly, the downside, lower performers, he is on the lower, so no lessons. He will only take the influence factor and will move according to that. So all those equations which I have derived, all the equations will be go according to that, right? In this human psychology updation equation, this is the final equation. In this final equations, you will see the two random number have used. One is the lambda 1, another is lambda 2. And here, this is the duty cycle, updated duty cycle. This is the past duty cycle. Lambda 1 is the random number. This is the mu. This mu is your excitement factor. 1 minus lambda 1, the same random number, 1 minus lambda 1 here. And this is your self motivation. Yes. Here, 1 minus lambda 2 is second random number, and this is your inspiration factor. And the second random number, this is here minus, I will use. Be sure that this is minus, and this is lesson factor. So through this, all the energy calculated to update for the new iterations. Also, in the terms of vectors, you can see the N1 to N6, all the vectorial representation means all the inspiration will look like that. Similarly, all the lessons will also vectors in a opposite direction, you can see. And this is self motivation and your excitement. And after combining all, you will see these are the vectors. And then by using these vectors, you can say, or energy levels, you will generate or update for the next iteration or perform better on the next. So like this thing happens. Similarly, in the whole algorithm, you will see these are the 4 algorithm parameters have been used, but this is not like that. Every parameters have also linked with each other. So this problem is based on one algorithm parameter, that is your omega. right? This omega, enthusiasm factor. This is the all factors means the all are the based, all are the function of that. So it only you have to tune only on your omega. Also, I will show the behavior, how the omega changes. Okay, leave that. Okay, in the next iteration, when all the energy will calculate, then again check the your overexcitement and depression behavior. Means when all the duty cycle will update, then again you will cross check your duty cycle, updated duty cycle value is beyond the limit or not. If it is beyond the limit, then only you will decrease your power and you will push back in the original operating region. Similarly, you will check the lower threshold value. You can say the depression level. If it is below that, then you will add some external energy to push back in the operating region. Otherwise, it is according to the updated value. So it will check in every iteration. And another new thing or good thing is here, all the updated population or all the updated variables will not directly participate in the new iteration. Here, according to the behavior or according to the performance, in previous iteration, all the particles will sort best to worst. In best to worst performance, all the particles will again categorize good, poor, good, average, and poor. And all the poor performers will not go in the next iteration. Here, for next iteration, all poor performers, means the downside 1/3, will replace by using or generating new chromosomes. Here, the one set of chromosomes means 1/3 new population will generate and replace all. Okay, in this chromosomes generate, here I have used the crossover and mutation process. Here, heuristic crossover and heuristic mutation process has used. This is the equation of the heuristic crossover process and heuristic mutation process. This heuristic crossover and mutation process will perform in between the first 1/3 best performers. Average performer will directly update and go in the next iteration as usual. But the first 1/3 best performer will go through this heuristic crossover and mutation process to generate the new one set of you can say 1/3 new population, which will replace the poor performers. So you can see the new chromosomes here. This is the global best performers, and these are the one set of good performers which are in the 1/3, and so they are interlinked with each other, and they will generate the new 1/3 chromosomes, and that chromosomes will replace the poor performers. So this, like this, each iteration will finish, and in every iteration, these particles, updated particles, will move in the new direction. So this is the flowchart of that, and the flowchart is the very simple one. It looking maybe zigzag, but it is very simple. All the according to the performance, we can say the achievements. According to the performance, you will give the rank, position. Okay. After that, again, you will calculate all excitement, self-motivation, and lesson and inspiration. Update, create all the energy for all particle, and then update that. And after the updations, you cross-check that overexcitement and depression according to that. And then send in the new population set, where the 1/3 new will create and the replace to the 1/3 poor performers. And then it will go back on the operation. So like this in each iteration it will happen. And what I have developed, this is not directly I have used on this problem. Before going on the final problem, I have also tested this algorithm for the mathematical benchmark functions. 23 benchmark functions I have used. Here, these are the mathematical benchmark functions that mainly for your optimization testing, right? So here 1 to 8 functions. These are very predefined benchmark functions are these are. Okay, though these are the unimodal benchmark functions. Unimodal means one minima function is that one. So function 1 to 7, this is unimodal. Another is multi-modal benchmark functions. Here multiple minima you will get, and in these situations how you are going to update. So in function number 8 to function number 30, this is multimodal. And the last one is your fixed dimension multi-mode benchmark functions. These are the critical problem in mathematical problem where to test your algorithm, what you are going to develop, right? So on these benchmark functions I have tested. So here after I have compare with the other techniques which are available in the market. So the first one is the gray wolf. Another is your PSO, the most popular one. The last one is D, right? Differential evaluation of the algorithm, right? So these three I have considered for your comparative study. Here I see for all functions, function number 1 to function number 23, which I have shown here, right? And in each sections, you will see the best and worst result. Here you can see this developed technique is performing better with respect to other, but not in each cases. In few cases, you will see the performance is very similar like other. For example, you can see here, function number 8, the best performance of all techniques are very similar, same. Similarly here, function 9, 10, 11, performance of this and performance of gradule are same. But in the terms of worst, you will see the worst performance, this is always better with respect to other. And the best is, in few cases, best is also giving good or maybe equal to that. So that is a good thing here. Another, I have performed the same testing for the 50 iteration for each problem, right? And on that basis, I calculated average and a standard deviation error, right? So according to the standard, I have calculated the average and the standard deviations, and you can see that. Again, this technique, developed technique is giving a good result, right? Similarly, average error, what is the error out of 50 iterations? So here again, you can see these are almost better. So with respect to the other techniques, these are the convergence curve. Convergence curve is for each function or each problem who is going to converge quickly. So you can see that the red one is the HPO, and you can see almost on all function, for all functions, HPO is going to converge quickly. But still, in few cases, you will not see like that. For example, function number 16, all are going to converge after a certain time. Similarly, you can see 18 also, 18, 17, right? So in a few cases, you will see the performance is very similar to the others, but most of the time you will see better and not poor, right? Not poor. This is a good thing here. Similarly, average function evaluation means the average iteration required to converge. It is based on the 50 iterations. So you can see I have used the AF calculations based on the 50 here. And so you can see that in each cases, SPO is taking lower time with respect to the all other. So this is the beauty of this problem, this technique which I have developed. And on that basis, I can conclude that exploitation, average local minima, and the average errors, everything, I can conclude that these are able to perform better with respect to others. Okay, so again, the same flowchart. This flowchart is I have derived for your problem. The problem is maximum power point tracking on a running vehicle, right? So this is the problem. Okay, so this is the problem. So additional thing also I have added here in the flowchart. So these are the optimization technique, but directly you can't use any optimization technique for this problem. Here also it is very important that you have to detect that. Detection means solar radiation change, because here solar radiation is changing. So here required to detect also whenever sufficient, or you can say significant solar radiation is changing, then you will explore your searching, right? When the solar radiance is somehow you're under changing, it will always change, but it is below your threshold value, then you will push all your iteration to converge, right? Means in a steady state conditions, you will say that converge. Whenever any dynamics happens, then you will push all technique, all agents to go back in the searching region and then explore your searching behavior and find the final solution. So this is based on the detector I have used for that. This detector is based on the power envelope. Here I created the one power envelope. When power change is below my significant threshold value, then I will allow to converge. Whenever it will change above my certain threshold value, then immediately I will stop my convergence, go back in the searching region. So like this it happens, right? So this techniques what I've developed is tested on the experimental setup. I will show the results for that. So this is the experimental setup, the solar panel. This is added is here, and this is again the boost converter, and this is the battery. This is simulation pattern, but I will show the two results. One is the simulation based result, as well as I will show your hardware result. I have done these things on experimental setup also, where these things are changing on every 1 second, and then how it is happening. Okay. So during this searching, I have considered the 5 patterns, pattern 1, 2, 3, 4, 5, and you can see how complex characteristics I have considered. In all characteristics, you can see the star one is the global peak, right, and the circle one is the local LMP, local maximum power point. And I have tested all algorithm, what PSO, ant colony, flower population 0.86, right? Remember initially I told that. So I have considered all for testing. So here you can see the simulation result. This one is the simulation result. which is based on the mathematical modeling and all. So this in this simulation result, this is the voltage, current, power, and duty cycle. Duty cycle shows your searching behavior. You can see the searching behavior, how the all agents are moving up and down, and then you can see the searching time is 0.48 second on the MATLAB. I've done these things on MATLAB. It is taking 0.48 second for searching. It means that 48% time for searching and rest 52% time for your optimal performance, or you can the full rated performance, right? So your efficiency will high. Similarly, I will show the experimental also, but this one is based on mathematics. So one another thing I have tested here, if someone is not ready to, not able to tune the algorithm properly, means the selection of algorithm parameter properly, then what will happen? So you can see here 3 things there, HPO 1, 2, 3, means I have taken the 3 type of your algorithm parameter, constant value, omega. So you can see different results. In the best one, the red one, the poor one is the green one. So in all results, you can see that every your algorithm parameter is able to track for different solar irradiance pattern within a second. Here you can see the best one is the 0.4 and the worst one, green one, is the 0.6 or 0.55. Similarly, here it is around 4 and it is around 7. Here again you can say around 4 and around 5. Like this means if you are not able to tune my algorithm parameter properly, then again algorithm will give better result with respect to the others, right? So this is the beauty of this technique. Also, you can see the searching behavior. This is a very common searching behavior. It starts always from the different locations, but finally it converges on the peak. I have also shown the convergence behavior. You can see here in this track, I will show how the agents are moving towards our global peak. Global peak is the dark red line. You can see that attrition changing 1 to 2, 3, 4, 5, 6, 7, and 8. In this, you can see that at the around 8, all the particles are close to our global peak. So this is the beauty of that. And out of all global peak, this one is on the global peak, where the operation or where you will be able to get the best result with respect to all of them. Okay, this is our experimental results. In this experimental results, means hardware results, you can see my tracking behavior, and here I getting the time is 0.51 second. This is the final benchmark timing for my algorithm, and means that 51% time for searching, rest 49% time for your full rated operation or your operation with a full strength. So again, on the all 5 patterns, you can see the patterns here. For pattern 1, it is taking 0.53. This is at pattern 2, it is 0.67. Here pattern 3, 0.48. Similarly, here 0.41, this is 0.47. So on this basis, I have derived here this is 0.51 second. But also I will say this is not based on this only 5. We have gone more than 500 patterns, different patterns in a loop by using your solar emulator, and on emulator by using DC-DC converter, where the solar irradiance are changing within a second, and then we have tested how it is working. So the approximate this time is the final constant time. This is 0.51 second. Also the efficiency, when you will see the efficiency, this is 0.99.98 efficiency you will get. Similarly, here you can get the 99.97. This is 99.99. See, this efficiency is MPPT efficiency. This is not panel efficiency. Panel efficiency is something else. Means how much power you are able to convert from heat, or you can solar power conversion into the electricity. The panel efficiency, right? Means the photons have how much energy, and you are able to convert into the electricity. That is 20 or 18% in general. But this is the MPPT efficiency, means how much power you are able to extract, which is on the panel. Means the 98% of the 20%, you can say like that, right? So this is the MPPT efficiency. Okay. Similarly, if suppose no shading, not necessary to always you will face the shading. Maybe this algorithm has applied on a open space. Then what will happen? If no shading, then again I have tested, and then you can see the searching time is around 0.34 seconds. Here these are the patterns 6 to 9, 6 to 10, and the global peak, or you can say MPP points are varying here and there. Then you can see these results. Also on the experimental setup, this tracking time is 0.37 seconds. Means 37% time for searching, and rest your 63% time for your full strength operation. You can see without shading condition. Also, you can see the characteristics also on the downside, where the efficiency is written around 99.99%. You can see that. but this one is your comparative performance. Here I have compared with the ant colony, flower population, and HPO, who have claimed that so they are able to detect within time. Then you can see here ant colony, extremely poor performance. You can say 3.12 second. FPO, flower population on simulation. This is simulation result. You can see 0.77 second. On HPO 0.48 second for all five. You can see these points are the movement of your particle or agents. Similarly, on the experimental setup, experimental results for all three, ant colony 3.42, FPO 0.83, and HPO 0.51 second. FPO 0.83 is not only due to me, right? Also, when you will see the paper, the author have also claimed this time. Author have claimed also 0.85 second, but in my case it is 0.83 second. But the time is almost same. What all author have claimed in the paper. The paper is in IEEE transaction on power electronics. You can see that paper where they have given these results. Here also I'm getting the similar type of result, and also HPU 0.51 second, which I have developed. So you can see that the differences. Also efficiency are more or less same, because when you will give the time, then efficiency you will get. But the question is not the efficiency, your timing is the most important, right? So finally, with all, I can conclude that. So here you can see this dots means the movement of your searching articles. Here PSO, ant colony, flower population, and HPO, you can say. The upper one is without shading condition. The downside is during your shading. And here the left hand side, you can see the simulation result as well as experimental result. And finally, I can conclude that HPO is able to detect very quickly, rapidly with respect to all the other available solutions, which timing is 0.51 second, right? And also, after all the discussions, I have tested all the algorithms also on the standard. According to the IEEE standard, the given standard is European standard EN 50530. This is the given standard, means when you are going to develop any algorithm for any type of solar irradiance operation, maybe shading or without shading, you have to test on this standard. Then only you can decide so your algorithm is able to use for your industrial purpose or not. And here criteria is when you will test on these equations or this pattern, then must be your efficiency more than 99%. If your efficiency is more than MPPT efficiency, right? If you remember, not panel. Okay, when your efficiency is more than 99% with your significant time, what time you are claiming, then only you can say you are able to use for industrial purpose. So, okay, I have tested also on the European efficiency and the Californian efficiency. In the European efficiency, you can see these numbers, the 5%, 10%, 20, 30, 50, and 100. The numbers means that this number decides the solar irradiance, means 5% time, 5% solar radiance, means the standard solar radiance is 1000 watt per meter square. Here this is 5%, means that you will operate your solar panel on 5% of 1000. It means 50 solar radiance, 50 watt per meter square solar radiance. When you will operate your panel on that and you will calculate the efficiency, you will write here. Similarly, you will operate on 10% of the 1000, means 100 watt per meter square, calculate the efficiency and write here. Similarly, 200, 20%, 20%, 200 solar radiance, 30% means 300, similarly 50 and 100. And accordingly, you will calculate your efficiency and put this equation. Then you will get the European efficiency. Similarly, you will see the Californian. California means 10%, 20, 30, and 50, and 75 and 100. These numbers have decided according to the pattern, according to the geographical location. In Asian region, this this efficiency has not derived till now, and we are working to give a efficiency standard for Asian country also. Currently, for Asia, Japan, Taiwan, and China and India, this solar variations I am analyzing, and very soon, most probably within this year, I will also try to publish this efficiency for Asian country also. But these are based on the European region and the Californian region. This efficiency based on the solar variation according to the geographical location, right? So, for example, here in the European, you can say this is the highest one is 0.48, means only 48% time you will get the 500 solar irradiance more or less maximum time in a year, right? Similarly, but in US, you can see the highest one is here, means 75%, means 750 watt per meter square you can get for 50% of the time. This is 0.53 seconds. So on that basis, a long statistical analysis, this standard researchers have published and given in IEEE. This is European standard EN 5053. I have tested also on this standard. Similarly, this standard I also tested on dynamic performance. For dynamic performance, the change has given. That was the steady state performance. This is dynamic one. Means your pattern, how your characteristic will change, how your celebrity will change. So you can see the two is that one is the low to medium. These are also according to the European and Californian, but for dynamic is constant for all, right? So you will give the change. Change is low to medium means 100 to 500 with a different slopes. Similarly, medium to high 300 to 1000 and with a different slopes. Okay. Here you can see the what is the meaning of those slope here. Here you can see the red one, upper one is changing, how it is changing. And this is the pattern, your solar irradiance changing. This is not the power voltage characteristic. No, this is solar irradiance. Your solar irradiance is changing with this slope, continuously changing. And then what is your efficiency? Also, you can see this is the on power, voltage, current, and duty cycle. What I got on this. This is around 3,600 second. Your all simulations, right? So it will take around 10 hours. So this is a long simulations. On that basis, this is calculated. Also, I have tested this same thing on the experimental setup. Also, on the experimental setup, you can see here what I consider. So here, single loop means one is the low to medium, and this one is the medium to high. So 100 to 500. This is 300 to 1000. Similarly, double loop means 2 times it will change in the first half and the 2 in the upper half. You can see that. So this is our obtained results which I have got on experimental setup. You can see the results. Again, this is a long hardware results. It is around 52 seconds here. You can see like that, and this is a more than 100 seconds is around. Okay. Similarly, on that basis, I have concluded that the efficiency. What is the efficiency? What efficiency I have got? So these are the efficiency. European steady state efficiency is 99.81. Californian steady state is 99.71, and the dynamic efficiency according to the pattern, right? So this is 99.49 efficiency I have got. So on that basis, I can conclude that or say that. So this algorithm is more efficient and able to detect within a time. But still, all the researchers have still option. So how to reduce this time, right? 0.51 second, right? Means that 50% time I am investing for searching, right? And 50% time for your study state performance. But question is how again you can further reduce that time. This is very important. Not on your simulation side, on the experimental setup. This is very important. So you can think about that. So this is the conclusion for that. But again, before finish my talk, few things I also want to share. So where you can contribute, what are the gaps is here? That is very important for a research point of view. You are listening all, it's okay, but still I want to enlighten some area so where you can think. In this whole presentation, I have shown 2 things. First half, I shown the when no shading, right? No shading means the classical technique, P&O, you can see. Whenever you use the P&O and all on the experimental setup, then you will get your tracking time is no shading, right? So 0.222 second. Within 0.22 second, you can track by using any classical mathematics, no shading condition. But whenever any shading will occur, then those technique will not work, right? So it's okay. When another way is that soft computing based GMPP, which I told, it's PO. Okay. In this result, I shown you when shading is there, then it will work with 0.51 second tracking time, and no shading. Without shading condition, its timing is 0.37 second, right? Informally shaded. But the question is how algorithm will decide shading or not without deriving the pattern, because you don't have pattern, right? During running operation, how you will decide the pattern. If you are able to decide the pattern behavior, then you can switch your algorithm or soft computing to classical MPPT or like that. So you can think about that, how you can do these things during running conditions. This is one area where you can think. Similarly, the 5G is coming in market. I am also working in this area where you can think also. So we all can contribute in this area. Means that in 5G, when 5G are coming, then vehicle to vehicle communication will start. So vehicle to vehicle means here my target is that particular region or particular zone, particular type of siding my vehicle will face. When the face, then my algorithm will decide an optimal point within a time. And my target is that I will collect those information, means optimal point with time stamp. At what time I got this thing. With time stamp, I will store in the cloud. So whenever a new vehicle, when the new car will come on those region, so for initial solution, as an initial solution, they can use my previous one. Definitely with time, pattern will also change. Area of the shadow will also change. Location, position of vehicle is also very important, where they sit. But I can give some initial solution so that that vehicle will use that solution which I have stored in the cloud. And this type of thing we can think, because 5G is going to come in market and vehicle to vehicle communication will start, right? So we can think about that. Just like now, so on Google, during your movement, you can see where is the traffic and what is the situation, right? And you can choose your path according to that. But this will very fast when the 5G will there. So we can also think about that. What are the information we have to include in the cloud? So next time when the any vehicle will come, they will use those, find the quick global based solution. So we can think about that. And third, the problem you can think about that charging side. Charging side means different type of charger are available in the market, no doubt we have. But the question is that in US or also in future in India, in remote location, means then far away from the city, government will install one panel. You can see that panel. So in the remote location, on a pillar, government will install one your solar panel and leave that only panel with two wire, nothing else, no converter, no inverter, no capacitor, nothing. Only on the pillar top one panel will be and the two wire will be for the emergency uses, right, on the remote locations. So in that situation, here required one charger who will do the two things, because you don't know the panel capacity, right? You don't know the solar radiance. You don't know how much maximum power. Suppose this maximum power is very high with respect to your battery vehicles. So here two things: operation, MPPT operation, as well as your charging current limitation. So how you will maintain your charging current? Means charging current is beyond the your danger region, or you can say inside the safe region, as well as MPP operation. So both will in the same charger. So how you will derive? So that a portable charger for both users. A single charger automatically will operate this panel on MPP as well as maintain your charging current. You can think about this, because this stuff, these are things will install in the remote locations for safety purpose. Okay, thank you. These are my publications. So with this, I am stopping here. If you have any questions, so I will happy to answer you.
Good evening, sir.
Thank you.
Good evening.
Good evening.
Okay.
Dr. Nishant, thank you very much.
Thank you, sir.
You had been a brilliant student at IIT Delhi, and you have a excellent work carried out during your program. So you have shared your knowledge, the thought process which you have already carried out for your analysis of different aspects of solar. I think all the participants have been benefited out of it, and they will be highly motivated with your speech, with your lecture, and will carry out the work in this direction in future. Thank you so much for spending valuable time for us.
Thank you, sir.
So I hope that we will be in touch in future as well.
Yes, sir. Sure, sir. Yeah,
so you have done really wonderful. I was looking at your the work which you have already carried out with a lot of transaction papers. So you are under postdoc program there.
Sir, this postdoc work has already finished. So now I am coming back India, and most probably in the first week of the August, I will join in. Currently, I am as a guest faculty. I am teaching in IIT Jodhpur. But after coming back in India for the first week of the August, I will start as a assistant professor job at IIT Jodhpur.
So thank you for your wonderful work which you shared with your participants, and So nice of you. Thank you very much. We will be in touch in future with you.
Thank you, sir.
Yeah, thank you very much. So
Thank
we
you.
can take one or two questions very fast.
Yes, sure, sure, sir.
Participants, they can ask questions directly. Yeah.
Yeah, good evening, sir.
Good evening.
Sir, this is Rahul Khajuria from JCT Jammu.
Okay.
I have completed my MTech in renewable energy, and my research thesis was also on approximately to your research area performance and comparison analysis of mono and poly under shading, dusting, and temperature. And it's really nice you have explained a wide aspect as it was not as I have not done such a what I can say a wide aspect of research, but some like similar. So, can you suggest me to go in future in this work? As now I am currently contractual professor at Jammu, but I want to pursue PhD. So I'm looking for different institutions. So this work is more suitable for me. So can you suggest that how can I improve my skills in this work? As my MTech thesis is closely related to your topic.
Yeah, that's good.
Yes, sir.
Your work is your work is mainly based on the uh,
Yeah,
performance comparison of different types of panel, right?
yeah, sir. Drawing IV characteristics and power curves, whatever you shown, that was done,
Yeah.
but not the algorithm you developed. It was not like that. Only
Okay,
the
but
experimental validation I did.
okay, but you can think also about the characteristics what you are deriving, right? So those characteristics are based on what? What are the variables you are going to use? And so you can think about that and the accuracy of that characteristics. For example, if you are going to use the temperature and how many solar temperatures sensors you are going to install, optimal solar temperature installations, or maybe you can use some prediction techniques to derive a characteristics more accurately by using less number of sensors. If you are able to do these things, this is very important because you know that every power system mathematical optimization people are waiting for that. Once you are able to derive a characteristics, this meta heuristic will immediately go out, immediately it will go from the market because the classical mathematics, classical optimization technique is able to detect the MPPT within 0.1 second, within 10% time. But the problem is characteristics. What you are designing and deriving. So question is how much sensors you are using, how much environmental, if you in environmental parameters you are using. So try to derive a characteristics with a less number of sensors or less number of parameters with a efficient characteristics. Efficient characteristic means it not mean that your characteristic is something else or the physical panel performance is something else, right? So you can think about those things. This is a very important and is a need of the market, but still, I think it is not available. So you can think about those things.
Okay, is there any other question from the participants? One
Good
about
afternoon, sir.
yes.
Good afternoon.
Sir, this is Jiten Singh from NIT Kurukshetra, PhD student.
Yeah.
Sir, you have developed a human psychological optimization algorithm.
Yes, sir.
So, how many tuning parameter is there in that algorithm?
I told one algorithm parameter is that is omega, one parameters.
Okay. And sir, the thing is how to decide the population size and maximum number of iteration for any algorithm.
No, it is totally based on you because definitely I will suggest that the keep your population size lesser. Just for example, I have taken the population size 5 only, right? Not more than 5 I have taken, but always take lesser and keep your try to make your tracking or equations is more complex or more efficient so that the less population means less information, right? So if you have the less information, then how your algorithm will perform more efficiently. That is the challenge here. If your population size is large, it means you have a wide range of information. Then you can take the decisions very accurately. But here, you know, the population size directly related to your timing because each population will take 10 milliseconds, 0.01 second. Then you think how much time you have for 1 second, and then you can decide accordingly.
And sir, what is the fundamental difference between heuristic and meta heuristic optimization algorithm?
Yeah. Yeah. Also, in the chat box, you have put it these questions, right? So, okay.
Yes, sir.
So, see, whatever techniques you are, first of all, the basic equation, basic definition, heuristic and meta-heuristic. Heuristic means a searching ability, means any problem, if you are able to find the solution, this is heuristic behavior. But the question is how you are finding the solution. During your finding the solution or during your searching the solution, if you are able to use some set of rules and regulations, those rules and regulations make your heuristic behavior to meta-heuristic. For example, whatever techniques you are using, PSO, whatever, then you will see always updation is based on certain rule, right? You have equations. For example, PSO, you are calculating velocity by using the equation omega plus, right, lambda C1, right? X1 minus base 10 minus against C2 and then lambda and then this thing. So this is the rule, means you are giving some certain rules. So you follow that, right? So this rules makes your algorithm heuristic to meta-heuristic. So whatever techniques you are using, these all are based on your heuristic, meta-heuristic behavior. So meta behavior, right? Meta-heuristic. So what all techniques are meta-heuristic.
Yeah. Sir, if I want to apply that HPO algorithm in my objective function, so where can I find the programming codes and necessary literature?
Programming codes are not available in the public domain, but yeah, papers are available in the IEEE transaction, one in IEEE transaction, one in IIT GTT. Two papers I have published on this HPO, and you can go get these things. And still, I am trying to improve this HPO, and then my challenge is that, my main goal is that, you can say, so within this year, I will publish this in IEEE transaction on you can say, what is that? Meta-heuristic optimization based one transaction is that, right? So I will try to publish there, as well as I will give the public domain codes also in different languages, means Python, MATLAB, C, C++, Java. So 5 language code also I am making, and very soon it will be in the market domain, public domain, but it's still not available.
Okay, sir. I will keep in touch for the work. Thank you, sir.
Thank you.
So with this, we came to the end of today's session. So thank you very much, Dr. Nishant, for sharing such a in-depth research in the area of electrical vehicle and its charging technique. So starting from the historical development you have started and you have covered till today, and what are the upcoming research work also you have suggested for the current researcher. So that is obviously all the participants will get benefited. So thanks a lot for your time
Thank you.
and accepting our request. So thank you very much.
Thank you, sir. Thank you, sir.
Thank you.
Dr. Nishant, thank you so much, and hopefully we will meet in future.
Yes, sir. Sure, sir. Thank you, sir.
Yeah.
Thank you so much. I'm happy.
Yes, please. Okay. Thank you.
Thank you, sir.